Welcome back. We're going to look at another application of calculus, this time involving economics. So first let's discuss some terminology that we need for economic study. We have marginal profit, marginal revenue, and marginal cost. Each of these are the rate of change of their respective thing. So marginal profit is the rate of change of profit with respect to the number of units produced or sold, and likewise revenue and cost. And some notations that we need: X can denote the number of units. R of X is the revenue. C of X is the cost. And P of X would be the profit. So the marginal profit would be P prime of X. The marginal revenue would be R prime of X. And the marginal cost would be C prime of X. And there is a relationship between these three things. The profit is equal to the revenue, the amount of money brought in, minus the cost. So profit is equal to how much money we brought in total from our product, but subtract off how much we had to spend to make that product. So let's look at an example now that we've defined these things. We have the cost of manufacturing fishing poles, good here in Arizona, in thousands of units is modeled by C of X equals this cubic, and the revenue for this is modeled by 7X plus 3. We want to find a production level that maximizes profit. So we want to maximize profit. Well, profit, if you remember, is revenue minus cost function. Okay, so we're going to do 7X plus 3 minus the cubic. Okay, so what we're looking for is the maximum profit. In other words, what we're trying to find is where the marginal profit is equal to 0. So let's rewrite our profit polynomial in standard form. We have negative x cubed plus 10x squared minus 13x plus 3. We want to differentiate. And set equal to 0. Solving this polynomial gives us x equals approximately 0.730 and x equals 5.94. Now, how do we know which one of these is going to give us maximum profit? Well, we can use a sign diagram. If we put in to our function for the derivative for our marginal profit, what we will find is that that marginal profit for, say, x equals 0 is, this is less than 0, p prime of 0 is less than 0, p prime of 1 is bigger than 0, and the derivative at, say, 6 is less than 0 again. So our profit, P is decreasing, P is increasing, P is decreasing. So max profit at x equals 5.94. Or what does that mean in terms of this actual problem? It means that if we make 5,940 fishing poles, we'll have a maximized profit. If we made 730 fishing poles, we would have a minimum profit. And then anywhere in between, we could calculate our profit based on these models. So there we go. There's an example with economics. There are other ways to use this. I encourage you to look at other examples that you can come across.